in the next example, at the very first sight, you might not see a relationship between the terms of this integral and the table of inverse substitutions. But you can rearrange these terms so that one out of these three categories will appear, right? So rearrangement in the sense you can just write this 4x squared plus 9 to the power 3 over 2 as 4x squared plus 9 and the square root to the power 3, right? So that's the same thing as this one, because now for any number to the power 3 over 2 can be considered as that same number to the power half and raised to the power 3. So this will be equal to the square root and raised to the power 3, right? Okay, but still, see, in this table you have, now you can see if this belongs to a category, it should be the second one, right? Because you have a addition in the middle, and the second category is the only one which has an addition. But still, even in this second category, you don't have a coefficient for x, right? It's just 1x squared, okay? But here in this expression you have 4x squared. So still we cannot directly use the second category, but we can go over with this situation by considering 2x as u, okay? So then the square root will be u squared plus 3 squared. That means we can use the substitution from the second category as 3 u equals 3 tan theta, right? So once we have this substitution, now we definitely know if we have this sort of a square root, then we know for sure that this substitution will work, right? And but the thing is, our actual relationship will be this one. In other words, 2x will be equal to 3 tan theta, or we can say x is equal to 3 over 2 tan theta, right? Now, so we should proceed with this substitution. So this is not exactly a one out of the three categories in the inverse substitution table, but we can do some little readjustments and get the appropriate substitution, right? And once we have this one, then the remaining part will be very much similar to the things that we did before. Now there's another thing here. They have given a upper limit and a lower limit, right? The lower limit, sorry, now here I have messed up with p and q. The lower limit should be equal to 0 and the upper limit should be equal to 3 by 2 times root 3. Now this upper limit might looks a bit weird, but when you are doing the calculation you will see that it is very easily, like it's somewhat easy for the simplifications, right? Okay, now let's see how we are going to simplify this one. With this substitution we can rewrite the terms as this one. So the term inside the square root will be simplified, as now here we are using the given, like the mentioned trigonometric relationship, and we will get tan theta, sec theta in the modulus, and you can get rid of the modulus sign by the angles they have given. And then to find the appropriate limits, because this integral comes with an lower limit and a upper limit, right? So for the lower limit, when x is equal to this one, now we should find what is the appropriate theta value when x is equal to 0. That means when x is equal to 0, this equation, the left hand side of that equation will be equal to 0. That means we can cross multiply this term and tan theta will be equal to 0. So since we have to choose angles from that given range, theta will be equal to 0. And then for the upper limit, when x is equal to the upper limit, this value will be equal to that upper limit. 3 by 2 root 3 will be equal to this one. So that 3, now this is the left hand side of the equation. So see, this is the reason that they have given the upper limit in a little bit complicated or a weird way. So the reason is that then you can easily cancel these two terms, right? So tan theta will be equal to root 3, and from the given range of the angle, this is the only possible one, right? So basically the upper and lower limits will be this one and this one for the integral. So this integral will become equal to this one, right? So now here we have x, like we should do the substitution properly, because it's a bit tedious with these fractions and stuff, but anyway it is not that difficult, because you have some easier simplifications when you substitute it properly. So we have these results, and then we end up with this integral, right? Now to calculate the integral of this one, we will need another I'm sorry, I think here it should be there's a small mistake here. Well, this is sine cube, okay? So sine cube can be written as sine squared theta times sine theta, and this sine squared term can be written as 1 minus cos squared theta, but still you will get another additional sine theta term. So this is the 1 minus cos squared theta term, but it will come with another additional sine theta d theta term. So now this is now when you have this sort of a format, I think we did it even in calculus 1. Now when you have sine theta d theta term and a cos theta term, if we substitute for u equals cos theta, then within the usual method of doing this substitution, we will get du equals sine theta, negative of sine theta d theta, right? See, now the sine theta d theta term appears in the original problem, so that will allow us to use this substitution, and it will simplify all the terms very easily. But don't forget that you will need another negative sign for this to work properly, because here you will need a negative sine theta term, but in the original problem we don't have a negative term, so we will need to put it by force, but to counterbalance it we should multiply it with another negative term. So the integral will become 1 minus u squared over u squared du, right? And then still it's not over, because we need to, now in this integral it was in terms of theta, right? These limits are with respect to theta, but now as we have converted our integral in terms of u, we should find the appropriate lower limit and upper limit, right? So when theta is equal to 0, u will be equal to 1, right? And when theta is equal to pi by 3, u will be equal to cos pi by 3, which is equal to half, right? So this will be 1 and this will be half, right? And also there is another result in integration, where if you have a b with a negative term, you can write the same integral with the limits upside down and without the negative term, right? So now as we have a negative term in the as a coefficient, we can get rid of this negative term by interchanging the two limits of the integral, right? So we can have half 1 minus u squared over u squared du with 3 over 16 as the coefficient. And then you can see that the integral will be simplified up to 3 over 32. So the final answer for the given integral will be equal to 3 over 32. So the important point here is that the integral, just by looking at this integral, we were unable to find a suitable category. But since we can extract out a square root term from the given original denominator, we did some little recalibration for the terms and then figured out a way to apply the inverse substitution technique. And in the next video I'll explain why this is called inverse substitutions.